Good morning once again, GLA middle schoolers. It's Mr. Manta. You already know that. We got another video lesson coming at you today. Learning today all about what is known as material science. Today's date should be Tuesday, May 12th of 2020, and we are on to lesson 16. We're getting into learning some really cool chemistry stuff. I think you guys are going to like what I have to show you today. I'm going to build in a few different YouTube videos, all kinds of fun stuff. But, as always, start with a do now. These are going to be 5 questions reviewing the stuff we talked about with atoms, molecules, and all the stuff we did with properties in yesterday's video lesson. So go ahead and pause the video and answer these 5 questions now. Alright, now assuming that you've completed that, let's see the answers. Number 1, true or false? Atoms are made of molecules stuck together. Ladies and gents, that is false. In reality, it's actually the other way around. If I had switched these words so it said molecules are made of atoms stuck together, then that would be true. Molecules are made of atoms. Atoms are not made of molecules. Number 2, true or false? A good chemist is able to tell what chemical something is just by looking at it. That is going to be false because oftentimes you have chemicals that look exactly the same as each other, and you need to test other properties that they have in order to tell what's what. In order to tell water apart from vinegar, apart from something like hydrochloric acid. In yesterday's lesson, we used those properties to tell baking soda apart from flour because they look very similar, but only one of them reacted with vinegar. So, for number 3, you can find out whether a white powder is baking soda or flour by seeing if it reacts with vinegar. That was what we mixed it with. Number 4, you can find out if a mystery chemical is a metal or not by seeing if it's attracted to a magnet, because metals have the property of magnetism. And number 5, why would it not be safe to drink a glass of water you found sitting in a chemistry laboratory? Well, there's a couple different ways you can answer this. Your words don't have to exactly match mine. But the idea is, it might not be water. There are some dangerous chemicals that look the same, that look just like water. So if you are ever hanging out in a chemistry lab and you see a beaker of some fluid that's clear and colorless, then you're just going to assume that it's water. That is a bad idea. You should not drink it unless you are 110% sure that it is water. You've been told that by a professional chemist. To review the stuff that we had talked about with atoms and molecules, this is always kind of my go-to diagram. It shows that atoms are these kind of individual little, here they're represented as spheres, that's fair enough, but atoms are these little individual building blocks of matter, and a molecule is made of atoms that are stuck together. And then I also wanted to remind you of this picture we saw the other day, showing that things like water, vinegar, and hydrochloric acid can all look pretty much identical. And you really can't tell them apart unless you test their chemical properties sometimes. A lot of people think that if something is an acid, that means that it's going to be like bright green or bright yellow and bubbling, and you can tell that it's an acid because it looks really dangerous, but that is not true. Most acids just look like this. They're just clear, just like water. You would not be able to tell them apart, and that would be dangerous. If you were in a chemistry lab where there were acids and you just assumed that you could drink anything as long as it wasn't bright green and bubbling. It's not true. A lot of acids look just like that. All right, moving right along. Today we're going to be talking about application. Well, what do I mean by that? I don't mean an app on your phone. No, not at all. An application means putting something to use. So far we've been talking about all these ideas in chemistry, the basic ideas behind how chemicals and matter and properties work. But we haven't really seen anything. We've done a couple things that were sort of practical, how you can use properties to tell apart different objects and figure out what a mystery object is. But today we're really going to talk about how people put chemistry to use. We've learned all these concepts that people use in chemistry, but so what, right? All these concepts, things like the fact that all matter is really made out of teeny tiny particles called molecules and atoms. The fact that the different states of matter have different things going on with their particles, such as in a gas, the particles bounce all over the place like crazy. In a liquid, they kind of swim freely along each other, and in a solid, they held together rigidly in shape. We've talked about all these different properties like hardness and conductivity and malleability and magnetism. Heck, we've talked about making solutions and solutes and solvents and what the difference between them is. We've talked about chemical reactions, like this video that I found of a really crazy looking one. We learned about chemical changes versus physical changes. And we've talked about atoms and molecules. Oh my gosh, all this stuff and more that we've learned in this unit. Hint, I'm including all this stuff because, yeah, we're going to start talking about reviewing for a test, but not quite yet. And you might be asking at this point, so what? Why, Mr. Manta, have we talked about all these different things? We've made solutions and talked about atoms and states of matter and everything. It's not just so that you guys can take a test. I mean, yeah, that's always part of it, but why do people in general bother learning about this stuff? Why is this in science class in the first place? Well, today what we're going to examine is that same question, right? How is chemistry used by scientists to invent things that make people's lives better? Because at the end of the day, science, yes, it's about learning about the world that's around you. It is a way of asking a question. But, if you're going to learn all this stuff, you might as well use it to invent some new things once you have all that knowledge and actually make people's lives better. It always bugged me in science class when teachers would teach us all this kind of science stuff and then never really talk about the point of it, about what we could actually do that would really affect my life, the lives of people around me. So today, we're talking about that. We're talking about applications. Today's big question is going to be, how can we use chemistry to invent new materials? I'm going to start off with a video from Crash Course, the first of several YouTube videos for today. We're going to be learning all about material science and materials scientists. Listen up closely.
Humans are great, aren't they? I mean, I know I'm biased, being one myself and all, but people have been responsible for creating some pretty amazing materials. Materials like the ones that are in the computer or the tablet you might be watching me on right now. And we're inventing brand new materials all the time. Hey humans, keep up the good work. But what about materials that have already been invented? Can we do anything to improve those? And if so, how? Well, I don't like to answer a big question without a quick recap first. Before we talk about improving materials, let's recall what a material is. Simply put, a material is an object that's made of matter. And all materials have properties. Properties are... Anybody? Okay, fine, I'll remind you. Properties are the qualities of a certain kind of matter, like its color, shape, size, temperature, or weight. So, properties help describe materials. For example, this desk is an object made of matter, so it's made of a material. It's brown, medium size, weighs maybe a couple of kilograms. Those things I just listed are the desk's properties. Got it? Great. I'm going to answer the first part of our big question a little early and tell you, yes, humans can improve existing materials. In fact, there's a whole branch of science devoted specifically to studying the properties of materials and how to make them better. Scientists who do this sort of thing are called, you'll never see this coming, materials scientists. Humans have been improving existing materials for a long time, since at least the 11th century. Back then, some early materials scientists discovered that the widely used material of iron could be improved. They found that by heating iron in a furnace with charcoal, they could turn iron into a different material we still use to this day. You might have heard of it. It's called steel. Iron's great and all, but steel was a major improvement back then, because it was a harder, less malleable metal than iron, and that made for better weapons and tools. Our ancestors really liked weapons. And tools. They like tools too. So now that we know we can change existing materials to make them better and more usable, let's take a look at how that happens. Maybe this time with a more modern example. Let's see how a material that we use all of the time can be altered and improved. In animation form, of course. Say hi to little Sabrina. Look at her tiny cute cell phone. Part of little Sabrina's cell phone is covered in a material you should be familiar with. Glass. When cell phones were invented, glass coverings were applied to their screens to protect them. But as newer, better cell phones were invented, newer, better glass began to be used in our phones. The piece of glass that covers little Sabrina's screen now is not the same kind of glass that would have covered her screen in the late 1990s. This sheet of glass on the left is the kind of glass that covered older cell phones. Think phones that came out before the first iPhone. The sheet of glass on the right looks identical to the sheet on the left, right? But it's not. It's something called Gorilla Glass, which is on little Sabrina's current cell phone and covers most phones today. So they look the same. But how did this become this? If you're thinking gorillas have something to do with making this glass, you're about to be real disappointed. Material scientists looking to develop tough, scratch-resistant glass for people like me who drop their phones all the time decided to give original glass, well, a bath. They dipped the less strong, crack-prone glass in a hot solution of potassium. The solution's extreme heat caused larger potassium particles in the solution to replace smaller particles of sodium in the glass. This exchange of particles changed the properties of the original glass, giving it more strength and making it less likely to crack. In the end, the bath gave scientists, and little Sabrina, Gorilla Glass.
So just stepping in here for a second, if you've ever wondered how it was that glass on your phone is made, it's not just normal glass, it's special glass called Gorilla Glass that was dipped in a vat of potassium in order to make it stronger than regular glass. getting back to it.
So the original material, the regular strength glass, was improved when its properties were changed. Which means, yes, humans can improve existing materials when they change the material's properties. This change can occur by adding new substances to a material, like the potassium particles in the glass, or by taking away some of its original substances, like the sodium particles. And this change in substance also changed the material's properties. So, to the scientist who invented Gorilla Glass, I and all of the other phone droppers out there give you our deepest thanks.
Alright, I'm guessing she is not the only one. I've definitely dropped a couple phones in my time, and I bet that some of you guys, maybe your parents have too, and we all kind of do at some point. It's difficult not to, right? So that was a cool little insight into this thing called materials science that is the basis of the way people invent new materials and use those to invent and improve the things in our lives. So the key point for today, definitely one you want to write down, is that the people who use chemistry to invent new things are called materials scientists. And these scientists are responsible for inventing all of the man-made things that are around you. And I mean like everything. Everything from the things that your house are probably made out of, like bricks and cement and mortar and steel and rebar, to your furniture in your home, to the pots and pans that your parents cook things with, and to, like Sabrina said, the glass that your cell phone is made of. They are all invented by material scientists. If you're wondering, the difference between a chemist, someone who just studies chemistry, and a material scientist is that chemists try to discover new chemicals, or discover the structures of chemicals, or like the deep science of just how chemicals work, the ideas behind them. Material scientists are like, okay, we need a new material to make a house out of. How can we figure out some new materials or improve some old ones in order to solve that problem? So they're more focused on like real world problems and solving problems that people have, instead of just discovering chemistry for the sake of learning about it. Discovering these new materials, and this is getting kind of a big picture stance for today. We're stepping out a bit and looking at why we do science in the first place. Discovering better materials helps society progress, helps things kind of get better for everyone. I want to try to explain this by making an analogy that I think a lot of you are going to get, maybe not everybody, to a little game called Minecraft that some of you have probably heard of, that I've been playing since, about the time since before some of you guys were born almost. Well, if you've never played Minecraft before, if you have played Minecraft before, there's a lot that goes on in it, and there's a lot of reasons it's a popular game. But one of the reasons why it's so popular is that in Minecraft, you progress through different materials as you kind of discover and are able to craft new things. So you start out the game, and you have to make a pickaxe to mine through some rock, and all you have is wood. You make a really crummy wooden pickaxe that breaks right away. But then you get some stone from that, and you're able to craft a better pickaxe that's stronger. Sometimes people make a gold pickaxe, but those are usually pretty crummy anyway. You make an iron pickaxe after you're able to find iron and smelt it, and then eventually towards the end of the game, you try to make the very best pickaxe of all, which is a diamond pickaxe. And because of this, you're able to build a better life for yourself in the game because you've progressed along and unlocked or found or discovered and smelted all these new materials. And now they have a new one called netherite that's bogus, and screw it. Diamond's the best. I like diamond only. But the idea is that, progressing in the game means getting better and better materials to make your tools out of. Well, Minecraft they didn't invent that idea. That wasn't a new idea. In fact, people have been inventing and discovering, you could say, better materials for thousands and thousands of years. So this is a really big picture idea. This is a key point number 2. I want you guys writing it down. There are historians that try to study the big picture changes that have happened in all of human history, who try to answer questions like, how did people go from being, cavemen, from just living in small groups and families thousands and thousands of years ago, to being people today who live in big cities and have computers and cars and all these kinds of crazy things that we have today. And the way that they understand that progression from cavemen hundreds of thousands of years ago to today is by thinking about the materials people had to make their tools out of. So, when they look at history, they divide history into 3 major ages based on the materials people were using. They say if you look all the way back to the cavemen up until, 8,000 BC, for thousands and thousands of years, they call that era of human history the Stone Age. You've maybe heard of the Stone Age before, if you've ever read a comic book or something about cavemen. But the idea was that there were these thousands of years where the only tools people had were what they could make pretty much out of wood and stones together. Whether that was like, and those just basic tools like an axe or a chisel or a weapon or a spear or something like that. And what people could do was really limited by the fact that all their tools were just made out of stone. Then, a few thousand years ago, some people discovered how to make this new material called bronze. That was a special metal that we're about to see a video of that was way better for making tools. And because they had this bronze they could make tools out of, that allowed them to build all kinds of other stuff, like better houses, and they could start building the first cities and pyramids and stuff like that in the Bronze Age. And then people discovered an even better metal to make things out of, and that entered human beings into the Iron Age. And that was kind of the beginning of really big cities and big armies and people fighting over, people being able to do things that we would recognize today as, major governments and cities and all these kinds of big projects. And it all rested on the fact that they could make tools out of iron, which was a way better tool than bronze. And bronze had been a better material than stone. And the progression of these materials, material science, had allowed humanity to progress as like one overall species. Now today, most people wouldn't say that we're in the Iron Age anymore because we use so many different materials that we make things out of. Steel and fiberglass and carbon fiber and all kinds of stuff. And scientists don't really agree on what we should really call the age of humanity that we're in today. There seem to be there's computers everywhere now, and that's really changing our lives. So maybe you could call it the computer age, or the modern age, or the technology age, or the everything age. I don't really know. But the point is that the progression of humanity from one of these steps to the next has been totally dependent on the materials that people have been able to use to make their tools. And so, I want to show you guys some examples of the different uses of these materials in making tools and the kinds of things that you could achieve with them. So we are going to go to YouTube. I have a whole bunch of YouTube videos queued up for you guys today, starting with the very first one in the Stone Age. So this is from a YouTube channel that I'm a big fan of called Primitive Technology. And this guy on this channel lives in Australia, and he makes the kinds of tools that people back when they were living the way they lived thousands of years ago used to make. So for example, in this video, he goes into the forest. He doesn't use anything except what he can find in the forest, and he makes a stone axe. So he gets some stones. He gets ones that are kind of nice and hard. They're a good shape. He sands them down so they have the edge. He continues to sharpen them down so they're sharper and sharper. And he goes out and takes a tree, cuts the tree down, builds it into a handle. He starts poking a hole into that tree branch that he cuts out. He eventually cooks it down with a really hot fire. He takes his stone and he jams it into the tree branch. And this is what people did for thousands and thousands of years to make their tools, because they would need a tool like this to go and cut trees and maybe fight their enemies and who knows what else they used to have to do. And then he demonstrates how you can use this stone axe, which is a Stone Age tool, to do something like chop down a tree. And it would be way easier than to try to, take down a tree with your hands or whatever else they would have. That would have been the best tool that they possibly had to try to chop down a tree. And even then it takes a long time. So that's an example of a tool that comes from the Stone Age. And if we had never progressed past the Stone Age, then we would all be living lives like this. Might be kind of nice, might be kind of difficult, who knows. I also want to show you guys a video from another YouTube channel. This is a channel called How to Make Everything. And it's this really interesting guy who's just really smart and is very crafty and has figured out how to make a whole bunch of different interesting objects. And in this episode, he casts a bronze sword. So he gets a friend of his who knows all about these swords. And basically what they do is they take this wooden box and they lay in that box a bunch of like sand and clay and stuff that's kind of soft. And
between the two layers
they
of sand.
take a wooden,
now take your sword
like
and you're going to press it in.
the
Yeah,
shape
that's good
of a
right there.
sword.
And then we're going to press it down with the lid of the box so it
And they press it into that sand so that it makes kind of a sword-shaped hole in the sand. A sword
goes in straight. Great. So then you put one hand on it, just kind of light loose grains of sand in there. Watching casting a...
They eventually pull it out. They make sort of a casting mold in the shape of a sword. They play with some balloon animals. And then what they do is they make bronze. To make bronze, they take these two metals called copper and tin. They heat up in ovens so that it's super crazy hot. using fire and fuel, and then they pour this molten metal. I want to play that one more time. So they melt down a whole bunch of metal to make bronze.
We were using fully melted.
And then this stuff is super crazy hot. It's liquid metal. It's glowing orange hot. They've cooked it so hot, like at 2,000 degrees or so. You have to get it to melt these kinds of metals. And then they take that metal, and they pour it into the mold that they had made to cast a bronze sword out of it. You can see even then it's super crazy hot. Eventually then they open up the mold, and they are able to get a bronze sword. And at first it's super rough and bumpy. It wouldn't be a very good sword. So then he takes these tools and he slowly kind of buffs out, or he sands out his sword in order to make this nice sharp sword that he has made of bronze. And then he makes a handle for it, he puts it all together, and he has a bronze sword. Just like that, which is pretty cool. And those are the kinds of tools people used for the next several thousand years after the Stone Age. Well, after the Bronze Age, which was when they used all these kinds of tools, we saw that they progressed to the Iron Age. Now, there are two kinds of metals that we use a lot today, which are iron and steel. And basically, steel is just a stronger, more refined version of iron, and you have to do a whole bunch of crazy difficult stuff to turn iron into steel. And one of those things that you can do is what they're doing at this factory in China that's a steel factory, where these guys have taken a giant lump of steel and they're trying to turn it into steel. And the way that they're going to do it is to drop a giant hammer on top of it. So watch your ears right now. It's going to be pretty loud. This guy's a dangerous job. And so both of those metals are still used all the time today, both iron and steel. Steel is a stronger version of iron. It took thousands of years to figure out how to turn iron into steel, because steel is even better, but there's some things that you can use both of them for. And then, we've talked about the Stone Age, and the Bronze Age, and the Iron Age, but I want to take a step forward into the Modern Age. In the Crash Course video, she talked about this stuff called Gorilla Glass. So this is a video from the company called Corning, and they're the ones who make Gorilla Glass, which then goes on your cell phones, and it shows how they make and then test this Gorilla Glass stuff to make sure that as much as possible it can be really strong, because we all drop our phones all the time and we don't want them to crack. So take a look at the way that they test their Gorilla Glass to see whether it's going to break when people drop it.
The company showed us how they torture their glass to get it ready for prime time in their labs in Silicon Valley. First, your traditional drop test, with this machine that's able to drop it at an angle.
So this whole machine that they're looking at here, this big blue thing, is just a giant machine, and all it's meant to do is to drop phones in a very specific way. You might be thinking, like, well, I could drop a phone. I could see whether, I drop my phone all the time. They built a whole, probably several $1,000 machine just to drop your phone and see if it breaks, if they drop it in the exact same way every time.
No surprise that the curve is the weakest link on the glass. The company said they tested Gorilla Glass 6 up to 2 meters, as high as this machine goes. They also have the tumble test to mimic the most hazardous environment of all, the purse. The phone gets put in with cosmetics, keys, and coins to see just how scratch-resistant the glass is. And my personal favorite, the Super Slap.
Look at this. So they're testing all these different ways just to break a phone screen. Problem that you often run into, like tumbling it around in this machine with all these other things you might find in a purse. And then this last one is the most absurd.
Personal favorite, the Super Slapper. This pendulum mimics the impact and is measured in joules of impact energy. But even Corning admits that the design of a phone can play a huge part in how fast that phone breaks. So we'll have to conduct some tests of our own once they hit the market, which could be very soon.
We've been sampling them for some time now, and they're actually designing Gorilla Glass 6 into their products that will launch later this year.
Does that mean the Note 9? iPhone 10 Plus? Pixel 3? Maybe.
And it's not just about making glass durable. Corning is also changing the look of Gorilla Glass.
All right, I'm gonna link you guys a lot of these YouTube channels so you can take a look if you want. But even these Gorilla Glass people, they've gone through 6 different versions of their glass now, making it stronger and stronger each time. And each time, these material scientists are able to make it even better. But I want to step this even one step further, because now we're kind of in the modern era. What kind of materials can we expect to be using in the future? Well, I have something of an idea, because I've been hearing a lot on some of these science websites that I watch about this new material called aerogel. And aerogel is this crazy, space age NASA material that is the lightest material on Earth. It's at least the lightest solid material that anyone's been able to invent. If you look at a picture of it, it looks like this. It is just incredibly light. It feels like you're not even holding anything in your hand. And yet it is incredibly resistant to heat. And so in this video, this guy right here, who has a YouTube channel called Veritasium, is going to take some aerogel that's been made into a foam, put it on his hand, and then shoot a blowtorch at his own fingers. Watch what happens.
I want to make sure that the fire, when it goes around your finger, does't hit the bare skin.
It seems like it's pretty thin around this fingertip here. Like, how thick should it be? You're making me nervous holding a blowtorch. Can I do the blowtorching?
Or you can do the blowtorching, absolutely.
Because I mean, if this goes wrong. So how hot is a blowtorch flame?
Well, it's really hard to tell with this thermal camera, but from our experience, it's usually, at least 1500 degrees C, and it can get as hot as 2000.
So yeah, this is very hot. All right, let's try it. This is so wrong.
You should be able to
That
get
looks
closer.
very hot there.
It looks like I'm toasting a marshmallow. Whoa, why is it flaming like that? And what is burning?
It's the binder burning out.
Correct. You should be able to just hold it right on there. You might have to
Finger
close.
hot?
It doesn't feel hot at all. My finger does not feel hot at all. That is insane.
So what's the non-flammable binder? Is it proprietary?
Proprietary.
I cannot believe how little warmth I feel passing through that. The FLIR 1020 thermal camera has different temperature ranges, and here the aerogel is clearly hotter than the 160 degree Celsius upper limit. What? So this was about almost 1,000 Celsius,
It still amazes me every time.
but behind this thin layer of aerogel, extraordinary properties and improving on.
He coats himself in a thin layer of dust of aerogel that is water resistant, and then he steps into a pool without getting wet.
I think there's a layer of air there right next to my skin. That thin layer of air is what makes my skin look silvery. Light from certain angles reflects off the water-air interface in what's called total internal reflection. That is very strange. This is a really cool effect. I mean, just besides the fact that I'm basically waterproof. I feel like this extra air on me is making me more buoyant than usual. Let me try coming out of the water and see if I'm still dry.
Look at
That is.
There's no water on him. He's not dripping water or anything. That's how amazing this aerogel stuff is. It can be completely water repellent. It can hold up to, incredibly hot flames, and it is one of the absolute lightest. It is the lightest solid material that people.
It's totally impervious. It does not penetrate in, and it can sit on water for months, and it will be just the same as if it was never wetted at all. You ready?
Can't make it.
I
It
guess.
stays dry no matter what. At least when you use that version of it. Sorry, I'm geeking out a lot about aerogel because I think it's pretty cool. I wanted to get back onto the lesson and give you guys your first for today classwork question. All right, enough YouTube videos. Classwork question number 1. Like I was saying, we don't really have a name right now for the age that we live in. Like these other ages were named after the most common material that things were built out of. So classwork question 1, I'm curious to hear from you guys. What name do you think we should call the current age that we live in? Like we had the Stone Age, the Bronze Age, and the Iron Age. Well, what do we have now? The computer age was my guess, but yours can be different from that if you want. Pause this video and answer classwork question 1 now. Alright, unpausing and moving right along. I'm assuming you've done that. Now you might at this point be wondering, who invents all this stuff? these amazing, this Gorilla Glass that makes all the new phones, or this aerogel stuff that has all these amazing properties, who invents all this stuff? Where could you go to meet these scientists and these engineers who make this stuff? Well, I spent 10 seconds on Google looking up the universities that you guys are very familiar with because your classes are named after them, and I found out that the University of Tennessee has a department in their school called Materials Science and Engineering. And it's an entire department of students and professors and really smart people who make incredible materials like these ones. And you know what else? The University of Purdue has a whole department on materials engineering and materials science, and they make all this stuff too. And of course, didn't think I was going to leave you out, Georgia Tech also has a school of materials science and engineering. And students like this woman right here, and all of our other students and professors, invent some of these incredible materials like Gorilla Glass and aerogel and all this other cool stuff that's changing the future and helping people invent new technologies. It's so cool. For my classroom question 2, I'm again just curious to hear from you folks. Would you be interested in being a materials scientist? Tell me why or why not. Pause this video and answer that question now. Alright, and we are assuming that you've now completed that. Moving on to our last step for today, which is the independent practice. Go ahead and number your notebook numbers 1 through 8, and here are your 8 questions. Some of them are from today, some of them are also from previous lessons though as well. Pause this video and answer these 8 questions in your notebook now. Alright, I'm assuming that you've now done that. We're unpausing and we're seeing our answers. Number 1, which kind of change creates a new substance? A physical change or a chemical change? That is some review. It is very important to know that it is always a chemical change that creates new substances. Number 2, the different types of atoms that exist are called elements. We learned that there's 118 different elements that exist, like oxygen and hydrogen and carbon, and we arrange them in the periodic table of elements. Number 3, people who invent new materials with chemistry are called materials scientists. Probably should have gotten that one. That's what today was all about. Number 4, historians divide the 3 major ages of history into the Stone Age, the Bronze Age, and the Iron Age. That was the third one that we saw. Number 5, which is stronger, iron or steel? I went over this a little bit quickly when that video was playing with the giant hammer, but steel is kind of the strongest, most commonly used metal that we have today. A lot of skyscrapers are made out of it, a lot of tools, all kinds of things. Number 6, the glass that most phone screens are made of is called Gorilla Glass. That's what we saw that video of. Number 7, how is this kind of glass different from regular glass? Well, you could say a few different ways. You could say that it's stronger, you could say that it doesn't crack as easily, and that's what makes it so good for making a phone screen out of, because a lot of people drop and crack their phones all the time. If you went super technical and you said it's coated with potassium or dipped in a potassium solution, then heck, count yourself correct for that too. And number 8, the lightest solid people have ever invented is called aerogel. It's that stuff that I was just showing you those videos of. It's really cool stuff, and I love watching all those videos about it. Alright, go ahead and star those questions you got correct. Fix the ones you got wrong. Tell me in the class week form, and that takes us to the exit ticket. I know the video is probably a little bit long today, but I tried to include a lot of cool YouTube videos, and I hope that made it worth it. Today's cool thing is that I'm just going to go ahead and link you guys all those YouTube channels, so you can watch the full versions of those videos, along with any other videos that you find interesting from these channels. They're so fun. All of these ones, I could spend days and days on. Oh, and since a student asked, Jernila asked yesterday on the phone, if you guys can do science bites, I'm going to say yes. Absolutely. I haven't had anyone do a science bite since we've gone online, but if you want to do one for me, please do. The rules for a science bite remain the same. You have to watch a video or read an article about something related to science. You have to write me, either in an email or a Google Doc or a Word doc, however you want to write it to me. 2 paragraphs. 1 paragraph summarizing what it is that you learned from the video or the article you read, and a second paragraph with your reaction to it, saying are there more questions that you want to ask? Do you think it was a good video? Or did you learn something new? Were you surprised? Do you think other people should watch that video or read that article? And if you do those science bites, I can go through and take any grades that you were missing or exit tickets that you didn't do very well on and change those to a 3 out of 3, give you some extra credit points. Alright, that is all that we got for today, folks. Take care, and I will talk to you tomorrow.